Hi everyone, and welcome back to A-level physics lessons. Today we're going to cover the photoelectric effect equations, and then we're going to practice some problems using them. So let's just recap a couple things from last time. Here we go. A couple of things that I wanted to recap from last time is that during the photoelectric effect, the interaction between the photon and the electron are 1-to-1, and so we'll put a single electron is freed by a single photon. And the second, so we put the reaction is 1-to-1. The second thing I wanted to cover is any additional energy i.e. more than the work function. Phi turns into the kinetic energy of the electron, and technically the photoelectron. So with those 2 points in mind, we can continue. And so the equations we need to look at is the equation HF is equal to phi, the work function, plus the kinetic energy, the maximum kinetic energy of the electron. So this would be the energy of the photon. The work function here, the minimum energy required to free an electron. I'll put in brackets min energy needed to free electron, and the maximum kinetic energy of the photoelectron. And so all of these quantities are in joules or electron volts, and you have to be consistent. So either this is in joules, or electron volts, or MeV. They have to be the same. Okay, so we'll put consistent units. And as always, consistent units are required with any equation that we choose. And so the question may arise, why is it kinetic energy maximum and not just the KE? And that's because most of the electrons need slightly more energy than the work function to free them, due to interactions with the other particles in the metal, i.e. the other ions. And so all we need to put down for this is only a few photoelectrons have Ke max. Most have slightly less. And so we may plot a graph of all of this. So if I was to take my equation as above, this photoelectric effect equation, let's highlight it. That's a key equation. Let's highlight it. Let's rearrange it for Ke max equals HF minus the work function. I'm now in the form Y equals mx plus c. And so I can now plot this graph with the following on the y-axis. This is my kinetic energy, the max Ke. And on the x-axis, we're putting frequency. We'll put hertz for this, and we can pick any energy we like. We can just put joules for this. And then what's going to happen is my line is, actually let's extend the axis down slightly further, make it clear. My line is going to look something like this. And then it's going to go up linearly. It's going to look something like that. And so here on my graph will be F0, i.e. the threshold frequency. And the gradient of this graph via so if we were to just, let's match these up to make it super clear. That's Y. X is my frequency I've put on the x-axis. Phi is my plus C, although it's negative, so we're going to see that it's negative. And my H is my gradient. So my gradient here the gradient will equal h, the Planck constant. And so this gradient is constant, i.e. is constant and will always be constant because the gradient will always be h. And so if we were to trace this line back, we would reach the intercept, the y-intercept, and this would be phi then. And we see that phi is a negative value in energy if we arrange our graph this way. It is obviously a positive value. It is a threshold energy. And then we've got a region here. Let's just keep it black. And so I'm generating, let's just be very careful here, a region where if my frequency is less than this, then I'll get no photoelectrons. And so we can color, let's choose a different color. We can color this region in. And let's label it. And so in this region, no photoelectrons emitted when F is less than F0. Which I'll get rid of that because it might confuse the graph. Okay, so let's take, so we've got our graph here and we've understood everything here. Let's do another graph just quickly and just to demonstrate the nature of the gradient. So again, let's quickly label and label down here. Now, if I were to say get two different colors, that's going to go for purple, and I'll go for blue. clearly these are the same gradient. But they have different work functions. So clearly this F0, F01, F02, the two metals have different work functions. Okay. Okay, good. So that wraps up the new knowledge, and that wraps up the new knowledge for this lesson.